Hey, this is Mr. Leach with Sims and Math, and today we are going to be talking about some geometry, specifically the terms reflection, rotation, translation, and dilation. I'll be doing this in Geogebra. You can acquire Geogebra from geogebra.org. You can run it off their website directly on a PC or tablet, or you can download the software. I'm using the downloaded desktop version. When given the option, select Algebra. Let's go ahead and turn the grid on. First, we need a polygon. Go to the polygon tools and select polygon. There is an option for a regular polygon, but I'm intentionally wanting not a regular polygon. Just click to add your dots and you see that it is making your polygon. I made mine this 7-sided polygon, or a 7-gon, or a heptagon. Come over to this tool. This tool has a lot of our geometric transformations. We'll be using reflection, rotation, translation, and dilation. So let's talk about reflecting about a line. To do that, we need a line. So let's add a line segment. You can add that line segment anywhere you want to. Click on the Reflect About a Line tool, click on the line, and then click on the polygon. Notice over on the algebra pane, we have A and then A prime, B and then B prime. So notice on the graphics pane, we have A and then A prime, and then B and then B prime. Let's color the second polygon something different. How about green? Alright, so let's observe a few things. One, if I move the polygon around, you notice that the green polygon, its reflection, moves around with it completely. Secondly, if I move around the line, the green polygon, which is the reflection of the blue polygon, is going to change. Notice if I move G, G prime updates as well. I'm going to move the line a little bit just to move this out of the way so we can talk about lines of symmetry. Let's draw a square. To do that, let's pick the regular polygon tool. I'm going to add a point at 2, 4, and one at 2, 2. And then it's going to ask me how many total vertices do I want. And I want 4, and it does the rest. And so there's my square. So how many lines of symmetry do you think there are in a square? If I was to reflect this square about this line, would the square essentially be in the same place? Well, let's find out. Click on the tool, click on the line, click on the polygon, and you notice it's not in the same place. Go ahead and color the second square green. I'm going to give you a second, move this line so that way the green square is on top of the blue square. One location for the axis of symmetry is directly in the middle of the square. Notice if I move O just a little bit, you'll see that it snaps into place there. You might have done a similar one, but horizontally like this. Or you could have noticed that it could have been diagonal like that. Or like this. So this square actually has 4 axes of symmetry. One additional way that you could check to see if something is an axis of symmetry on GeoGebra is to actually sort of kind of draw on the shape. To do that, let's add a point. Let's color that point red. Let's reflect this point about the line. Notice it's P prime. I'm going to color P prime to be pink. Click on the arrow tool. Let's move P to J. Right click on P and P prime and turn their traces on. I want you to slowly drag P towards M. And you notice that the pink line followed that directly. Let's move P back towards J, and I'll move P down towards K. And notice that pink dot traces over to K, following the other side of the square. This shows you that this diagonal line in O is an axis of symmetry. I'm going to undo a whole bunch, so the only thing I have left is my original 7-sided polygon. Alright, let's go through our other tools. Now let's talk about rotating around a point. So let's add a point. Let's pick our rotation tool, click on the polygon, click on the point. And you see that it asks you a question, to what degree do you want to rotate? So here it says 45, so let's pick 45. And does just that, it rotates at 45 degrees. Now I want to make this a little bit more interactive. I actually want to interactively adjust that angle. So undo, and now let's add a slider. And let's pick an angle, and that works from 0 to 360, and it's alpha. Click on my rotate around a point, click on the point, click on the polygon, and instead of 45, I'm going to select alpha. I colored the rotation green, and so now I can slide alpha around, and you see that that rotation is just moving around that point H at that prescribed angle. When it hits 360, it's on top of the original, and of course if it was back on 0, it never moved. Often in your geometry class, your point is usually at like 1, 2, it's usually on the origin. So if I was to move this on the origin, I can do the same thing. So now this point is rotating around the origin. I'm going to undo, but making sure to leave my alpha slider. Our next one is translating, and this one is going to be translating by vector. So first we need to create a vector. So go over to our line tools and select vector. Our vector, we need a starting point, so just pick 2, 1. And we need an ending point. Notice it has an arrow, so let's put it over here at 6, 3. So let's use the tool just like we've been doing all the others. So translate by vector, click on our polygon, click on our vector, let's color it green. Take a look at point D here. This D clearly has moved over 1, 2, 3, 4, and up 2, which is what's happened with this vector. It's gone from 2, 1 to 6, 3. Back when I created H, or when I created this vector, I intentionally did not put them on the origin, because once it's on the origin or one of the axes, Geogebra thinks that it belongs on those places and it doesn't really want to move them. So now if I want to move I and put it on the origin, and then move J around, I can do that pretty easily. So notice here, this vector is beginning at 0, 0 at the origin and moving to 5, so this polygon is just slid right 5. If I was to have this go down 3, it would do the same thing. It could be going left 2. It could be moving up 3 to the right 3. Anything like that. Notice it is not rotating. It is not spinning. It's in the exact same orientation as it has always been. It's just merely sliding around. Notice all 3 of these, the shape didn't change, nor did the size, only its location or its orientation. So next we're going to be talking about dilation, and in that one, the size does change. I used the undo tool until the translated polygon disappeared. I still have my vector. Now let's use our last one, dilate from point. We already have a point H, so we're going to use that. And let's use the dilation. So let's click on our polygon, click on our point. And up pops a factor, so it wants me to see, well, by a factor of what? So let's just pick 2, see what happens. Whoa, that got really big. That's a little bit hard to see. You zoom out. Okay, you can actually see that a little bit clearer, that this polygon got twice as big in relationship to where that point is. But just like I did with the angle, I want to make this a little bit more interactive. So I'm going to undo that, and I'm going to add a slider. This one's just going to be a number. Geogebra will pick a letter that is unused, so H works. And so now when I use the dilation tool, I'll select H as my factor. Click on the polygon, click on the point, select H and say OK. And let's color it green. And so you notice that the polygon is in the exact same location. It hasn't moved. That's because our H is 1. So slide H and move it up to 2. And you'll see that this is what we had a second ago. Let's move H to the origin. Usually it's a dilation with respect to the origin. So the center of the polygon is changing because its center is not on the point in which it's dilating. So what I'm going to do is I'm going to move our original polygon so that way the center of that polygon is about over the origin. So now whenever I adjust H, it feels sort of kind of what you're expecting. But know that that's often not the case. If the center of this polygon is not centered on the dilation point, the center of the dilated polygon won't be in the same place. One more thing to point out about dilations is that you can also have a negative dilation. Notice what it's doing if it has a dilation of negative 1.4. It's taking this point A, multiplying its x value by negative 1.4 and its y value by negative 1.4, and it's getting this. Same thing with E. It's taking E, multiplying its x and its y by negative 1.4, and that's why it's changing quadrants. One way that we could do multiple geometric transformations is we could do, like, let's say, this dilation by negative 1.4, and then translate it by this vector, and then rotate it by that point, or something like that. So if I was to translate this by vector, I could click on this vector, and then click on my dilated polygon, and now, notice this is E double prime and F double prime. That's because I have a dilation happening, and then a translation happening. And then from That one, I could even, let's say, rotate. I could rotate this polygon around this point at alpha. And so now I have a dilation, and then a translation, and then a rotation. As a challenge, I want you to take this square that's in the second quadrant and reflect it, rotate it, translate it, dilate it in any order that you want to, in any orientation that you want to, so that way we end up with a square just like this in the third quadrant, in the fourth quadrant, and back in the first quadrant. Take a second and try that out. Before I reveal how I did it, if you need to visually see what the end result needs to look like, take a look at this. Alright, now, there are lots of ways you can do this. This is the way that I did it. Notice it's poly 1 prime, poly 1 double prime, poly 1 triple prime. So I got this polygon from the second quadrant to the fourth quadrant by using a dilation around the origin with an h of -1. So you can see here. Then, in order to get the polygon here, I just translated it left 5 units. So it was right here, and just translated it left 5 units. And lastly, to get this polygon in the first quadrant, I just rotated it 180 degrees. Notice there are a lot of ways you could have done this. You could have done the same dilation I did and then reflected it across the y-axis and then done the rotation. You could have translated it to the right and then done a similar dilation but around a point about right here, and then rotated it around a point right here. There's lots of different ways you could do that. This was just the one that I came up with. I hope you better understand the geometric terms: reflection, rotation, translation, and dilation. Feel free to play around with them and get creative. Have fun!